Unit 1 Chemistry, Chapter 7, looking at the shapes of molecules and how that affects the bonding between molecules here. Okay, so the shape, fairly obviously, is the way the atoms are arranged. Okay, remember that all electrons are negatively charged, so they're going to repel each other. So the stable shape that a molecule assumes is going to be whatever shape gets those negatively charged pairs of electrons as far away from each other. And for this, it doesn't matter if they're bonding or non-bonding. Okay, they still repel. Now, a double or a triple bond obviously is going to force a big cloud into the middle between the two atoms. So it's going to force those ones to be close together. The other ones are going to get even further away from them. Okay, so the shape is going to be dependent on how many bonding pairs we've got and whether we've got single, double, or triples bonds. So, we think first of all about just single bonds, and then we'll come on in class to look at some more complex ones with double bonds. Okay, so methane. It's a simple example where we've got carbon surrounded by 4 hydrogens, so every pair is a bonding pair. Now, to get as far away from each other as possible, they're going to assume this shape. Now, you're going to look at that and go, hang on, these ones are really close to each other. They look like it. This is a 2D representation of a 3D shape. What you've actually got is a central carbon. Okay. This sticks up from it. This one sticks out downwards, but going backwards. This one sticks out downwards, but going backwards out this way. And this one sticks out downwards and forwards. What you actually find is you have the same angle between all of them, which is an angle of about 120 degrees. And you'll see all the way across here that you're getting that same shape because that is where we get the electrons furthest apart. Okay, so we get the lines in the same place. This here is called a tetrahedral shape. We'll make some models so you'll be able to see them in class. Now if we think of ammonia, ammonia's got nitrogen and 3 hydrogens around it and 1 non-bonding pair. Okay, so we still get these 4 pairs of electrons repelling each other in exactly the same way, and therefore the same angle between them. But there's no atom up here. So this pair here isn't actually contributing to the shape. Okay, so if we look at the space-filling model, and we compare methane to ammonia, what you see is this one up here is missing. So that's obviously changed the shape. We now have a shape which we call a triangular pyramid. If we go on to water, oxygen, with 2 hydrogens and 2 non-bonding pairs, the electrons are arranged in the same way, but now we've only got 2 atoms stuck onto it. So we get, when we look at it here, it's called a V shape. It's an upside down V, you can see in the red there. Okay, on this line here, it's only the atoms and the bit in red that's contributing to the shape. Might help you to understand. And then finally, if we've only got 1 single bond, so like hydrogen fluoride or hydrofluoric acid, then we just get 1 line between from the hydrogen to the fluorine, so we'd call that a linear shape. Okay, we'll try out making some models so you can get an idea of how these shapes actually look, and then we're going to try adding some double and triple bonds into them and see how that affects the arrangement of those atoms.